Hi there, this is a tutorial for the RFG 1250. It's an advanced energy 13.56 MHz generator typically used in the semiconductor industry, although it can be used for other applications. But let's have a look at it. We can quickly type it into the internet. RFG 1250, and hopefully we should get some images up. There you go. Images. So these images are obviously freely available on the internet, and this is the basic unit itself. It's kind of a shoebox shaped unit, quite long. It's actually quite a lot heavier than it looks. Water cooled. It has various different types of power sockets available in it. It can be obviously like a cable, three-phase cables, three-phase supply. It can use a Hartnell connector, it can use this other type of Hartnell connector, blah blah blah. The water connectors can come in different styles depending on the model. We've got these types with the John Guest on it. We've also got the type which is the metal water fittings, which is typically more to do with the K series. There's a few more which are a bit more. This one I think this is a Hartnell as well. Not as typical, but you do get it. We'll go over the models, different types of models, things like that as well. But first of all, if we actually look at the unit at the rear, I'll find a picture of it. Here we go. This picture's freely available on the internet. It's got no copyright on it. It's got a 25 pin D-sub connector at the back, and there's also an output connector at the back, which has got an interlock on it. If you actually look just here, this little metal paddle, this acts as an interlock for the RF cable. And we'll go over the connectors at the moment. Hold on. Now, I've had to change some things around, so you might not recognise the names, but this is all for so people don't complain that I'm doing things I shouldn't. So if we just go over it quickly. Pin 1, set point status. This is basically indicates when the power, if you get a demand signal, you send say, a 5 volt demand signal and you're expecting 650 watts back or whatever, and it doesn't get to the 650 watts, it will give you an alert signal which will be sent to the tool or remote control or anything like that. I'll go over the remote control shortly anyway. Reflected power monitor will give you 0 to 10 volts signal for 0 to 250 watts for the 1250 model, and it's so 500 watts for the 3000 model. Forward monitor again for pin 3 does the same, 0 to 10 volts, gives you indicates 1250 watts. So obviously you do division of that. RF on command is used to turn the RF on. We'll go into that later with the remote control. For demand, you apply a 0 to 10 volts signal, which will give you 0 to 1250 watts or 3000 watts, whatever else, depending on the model again. 24 volts supply, which can be used to do various things. We won't be using it at the moment. RF status return, this is part of an indicator circuit, so the tool or your remote control tells you that the RF is on. Pin 8, not used in all models, gets used in other models. Pin 9, overheating return, is basically if you've got an over temperature fault, this will give an indication, shut the tool off, shut the signal for the tool off. Interlock circuit pin 10, which will look the pin, I think it's 23, that will defeat the interlock, so you can actually bring the power up, the AC power on. AC present return, this is an indicator as well, which tells you that the plus and minus 150 volts to the inverter card is there, present and correct, and will give you a return signal telling you the power supply is okay, or the inverter power supply is okay. CEX sig present, but I'm not really bothered with that at the moment, but if I just quickly show you, it's there. Sorry about that. You have a sync signal you plug in now, which we'll go over later, but that's what that's for anyway. 15 volt supply unregulated, which comes from the power supply. can tap off that. Set point return and reference for pin 5. 15 again is the same for pin 2. 16 for pin 15 for pin 3. Pin 17 on signal return, which is part of the opto isolator circuit which turns RF on, blah blah blah, which we'll look into and explain. Forward signal return, which is for pin 5. 15 volts and 24 volts common path, which is basically chassis ground. RF status collector, which can be used in different ways. If you're using it at remote control, then you can use it to sync or source a signal to give an indicator. If it's for the tool, it's the common path. Obviously your emitter can be used for as a return. Pin 21, same as pin 19, it's a return, it's a ground, indicating overheating indicator for pin 22 as well. Pin 23, yes I was right, is interlock. AC present, the collector, which is the opto isolator, which is an indicator as well for remote control or tool, and CX sync common, again same thing. What I mean by most of these is on, let's say, pin, use this, pin 3, we have the forward monitor. So if you get a 25 pin D sub male connector and make it yourself, and you want to make up yourself a remote control box, you would take that out, and what you would do is you would then use a small probe point and get yourself a banana socket, put that in, so test point, and that would then be 0 to 10 volts, 0 to 10 volts, sorry about that, 10 volts, and that will give you your 1250 watts. It's an indicator for your 1250 watts. So, not the greatest. That's your 1250 watts. So that's all. So for each volt, for 1 volt, you're getting 125 watts. If this is linear, obviously you want to check linearity. That's we'll go into that later as well. So that's the same for pin 2 as well, reflected monitor. You would get your 0 to 10 volts out there as well. Now your RF on command being how that works. Now I'm not going to explain everything for you to everybody because you need to go and work some of this stuff out yourself. But basically the basic concept is you have a opto isolator, an input signal. So it's a package like this with the return, and you can apply up to 15 volts. And there's an internal resistor in there which will turn this diode on, and then inside here you'll have a collector acting as an opto, as acting as that part of the isolation circuit, which will then go and return it and switch on the electronics, defeating obviously that, well, not defeating, but turning the RF on. That's how that works. So if you see anything that's telling you to do that, RF on, any kind of command, RF on command, to turn that on, that's what that's there to do. Most everything else is signal out, it's telling you if there's an error. The between pins 10 and 23, it's very simply just, you can either use a bridge wire, which I do not recommend. In case of any accidents, you should be using a switch of some sort. Normally that would be some kind of emergency throw. You can build that into your remote control, or you can just use a simple toggle switch, but obviously be careful in case something goes bang. If you've got a push button, push for off, in case there's any accidents, that'll help you. What else have we got? That's RF status return. Again, if you've got RF status return or any returns which I've just explained, what you've actually got on the outputs is the reverse of this. So, Internally to the unit will just turn on a dial package, and on the way out we have a collector, like so. Now, what we want to do is, external in a remote control will have a resistor, and then we'll make ourselves a diode, an LED, sorry, which is a diode obviously. We'll do that, and then what we'll do here is we'll tie that to ground in 19 or whatever, like so. I'll let you work out the value of the resistor in the diode yourself, should be able to do that. So when this turns on, it gives an indicator, so you get an RF on signal, you put the RF on, like that, you've got your interlock, you've got other interlocks and everything else. This turns on, it'll give you an external indicator. You want to obviously check this, make sure it's there, so that you send anything back to customers or if you're using it yourself, that all the indicators are working properly. Let's just see internal return, AC present return. This is an indicator for the power supply. We'll go into that later. We're going to make everything kind of tie up. But the most important thing is that you actually have the interlock 10 and 23. Make sure that's enabled. Make sure your RF cable is firmly screwed in so that the paddle interlock is there. You have 15 volts between pins 4 and pin 17, and that should bring the RF on. Now all the returns, although the signal returns are actually referenced to the negative of the op amps, really what you can do if you're using a remote control is you can tie all those together and tie them to pin 19 or pin 21 as a common reference. So what you can do is, if you make up a circuit, like so, where is it, pins 15 for the, so what we want to do is pin 15, like so. We'll get ourselves a 10 turn 10k potentiometer, a Bourne's or whatever, V-shape, and then you can tie that to pin 19 or pin 21, and then the wiper, you want to take that to pin 5. Pin 5. And this will give you your 0 to 10 volts here. You can go above that. I want to try and avoid doing that, so I'd probably try and stick a Xena diode or something in there just to prevent any accidents going above. It doesn't have any effect. No, it shouldn't damage the op amp or anything like that. The only thing that will happen is you'll hit the top end of the generator. The generator can go above 1250 watts, so you'll end up going above that. You don't want to do that. The generator will go into power limit anyway. But you don't want to force it, so you want to actually try and clamp that at 10 volts if possible, or just slightly above 10 volts so you don't overstress the generator. And that's that at the moment. If you're just doing a basic test to actually get see if there is any power coming out of the generator, then that's a quick way to do it. I'll go into more kind of technical explanations shortly. But if you have any other questions, just let me know and I'll get back to you. Okay.